Yay!
Perfect.
Woo!
Okay. So, question 3. The blood types and the proportions given in the table above define a probability distribution. True or false?
That is true. That is a probability distribution.
Yes. I agree.
Mm-hmm.
Okay. Question 4. What is the probability that a randomly selected person in the U.S. has type O blood?
Around the two decimal places.
So that's where we have to do the calculation.
But how do we know an accurate number?
Right. It can't just be 1 in 4, as we read learned in the reading. Trying to remember the formula because I just read it today.
Okay, the probability. Okay, so the part of the book that says randomness, I think I understood that something random is not that random.
Yeah, it's not completely random as people would think. I did gather that. But we can't just say 1 in 4 because there was a question in the homework that disproved that, or in the reading, that's not as accurate as what they're looking for.
Mm-hmm.
That's what I gathered. Did anybody else catch that?
Yeah.
I'm getting to the reading.
Because wouldn't we go off of, well, I don't know, these proportion numbers. I don't know.
Right. I'm just about there, getting into individual preparation. It would be under rules of probability, right?
I would think so.
Yeah.
But the first rule is probability of an event X is a number between 0 and 1. That's the first rule. The second one says that you have the sum is equal to 1. And the other one is this complement rule. The probability that an event X will not occur is 1 minus the probability that it will occur.
Right.
So
is it 25% is the probability?
I don't know. I think we're supposed to base it off of this chart.
Uh-huh.
And if it is based off of this chart, then the answer will be 0.45.
0.45. Oh, based on that. Based on the chart there. I see. I follow where you're going with that.
So it's going to be 0.45?
I think it is.
Okay.
Because we're supposed to use that chart for the next 3 questions.
Oh, okay.
And if that is the case for number 4, then number 5 will be 0.55.
5.
Wait a minute. No. So you're saying 0.45?
I'm saying
I could go with that
for number 4.
Yeah, I can go with that.
Okay.
So then type O blood. Oh, wait. Oh, then 0.55. I follow you. 0.55. Gotcha.
The rule, right? 1 minus.
Yeah, it's following in that rule. Absolutely.
Okay.
Does everyone agree with that?
I don't understand question 5.
Okay, so number 5, it's saying everyone but type O. So if it is according to the chart above, then you would add up the proportion of A, B, and AB. So it'd be 0.40 plus 0.11 plus 0.04. And that would be 0.55.
Okay, I got it.
Do you agree with that?
I'm just glancing back over the reading and just make sure we're in the right aspect. That sounds right. I'm just glancing over the reading. There it is. All right, so next question.
Okay. Caroline Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tingle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as bladder cancer patient. So, if the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder?
Essentially, using the same logic, it'd be 1 divided by 7, right?
Yes.
So 1 divided by 7 is gonna be 0.40, 0.1428.
0.1428.
So it'd be 0.143 because we have to round to 3
right
pieces.
Okay. So 1, 4, 3.
Do you agree with that, Abraham?
Yeah.
Okay.
Yes.
Everyone's in agreement?
Yeah.
All right. Number 7. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? I would say there is little evidence that dogs can detect bladder cancer.
Yeah, because it is less than half the time that they're detecting it. So I would agree with little evidence just due to the fact that it's less than 50%.
So there's little evidence that dogs can detect bladder cancer?
Yeah, little evidence, yes.
Okay.
All right. So in this one, are we supposed to on number 8? Do we consider green? since they blocked out the number?
I think we still do.
Okay.
Here, let's see. Yeah, we still have to because the second or question number 9 talks about green.
Okay. Okay. So this is just like the 6-sided dice question that they talked about in the reading.
Right, but I think this one is again based on the chart.
Based on the chart? Okay.
So if that is the case, then I think the answer will be the 0.13.
0.13, yeah.
And then what is the probability?
I want to say that that seems kind of too easy, but
it does seem really easy.
Yeah. It can be tricky though, so.
Yeah, it can be tricky. I agree.
Like too easy to be true.
Yeah.
Right.
It is. It is pretty tricky.
Well, see, so here's the issue with the green candy now. They have the number blocked out, so that kind of leads me to believe that we have to do some figuring.
0.16. I add the total numbers, and it's 84. 0.84, and we are supposed
to have to sum up 100, right?
Yes, and it's 0.16.
0.16. Okay.
Oh, there you go. Okay, 0.6.
That's for green.
Yeah, for green, because like Abraham's pointing out, it's got to total up to 1. And so that's all that's left is 0.16.
Okay.
0.16. So, okay.
So then it's 0.84. It would be the answer to the question 10.
Yes.
0.84.
Okay. Mm-hmm. 1 minus.
Okay. So question 11. Half of the observations are less than or equal to what number?
Okay, so where are we getting the information from?
From the chart above. The numerical descriptive statistics, the ACT scores.
I don't see the chart.
It's not popping up on yours?
No. Oh, there it is. I have to click on the icon.
Okay.
It's not populating on mine. I just have an icon.
Okay. Here, I'll share my screen.
All right. Okay. Mm-hmm.
So I think.
So then, what's our question then?
So it says half of the observations are less than or equal to what number?
Oh.
I wonder if we have to put, because it doesn't say anything about decimals.
So it will be a whole number?
The median is 24. So it's going to be equal to or less than 24 because 24 is the middle.
Oh, wait, there's bigger numbers than just 24, though. There's 27 and 35.
Uh-huh.
So I think it's going to be less than or equal to 35.
Half of the opposite, but But they're only
Okay.
wanting half of them.
Oh,
So yeah, it's gonna be the medium.
Yeah, so 35 is the max, so all of them are going to be less than 35.
Mhm.
okay.
So if we get the medium, they will be equal or less than 24.
Mm-hmm.
Yep. Okay. So 24.
Yeah.
Okay. Based on the information on the table above, the top 25% of the students scored above what number?
That's a Q1,
It'll be
right?
that 27, I believe.
Yeah, it's the Q3.
Uh-huh.
Oh,
All right.
so 27. Okay.
And then which of the following statements is not one of the 3 rules of probability?
The 3, I said, is the probability is high, then the probability is positive. But we know that there is no negative in probability.
Right.
So.
I agree. It's going to be number 3.
Okay. Perfect. Here, let me submit mine first, so you guys don't submit it real quick. Okay.
How'd we do?
We got one wrong.
Uh-oh.
Oh.
Which one?
It looks like it's number 7. Oh, that's weird. Okay. It says that you can provide strong evidence.
Okay. So then all the others are right then?
Yeah, all of the other ones are right.
Oh, which one we're on?
Number 7.
7. Oh, okay.
Mm-hmm.
Let me correct that one. Okay.
Okay, I just have a question about question number 6.
Okay.
Is
Sorry,
0.143.
Are you there, Abraham?
yes, but
Okay.
Okay, so the answer would be 0.143 because you're doing 1 divided by 7, and then the answer comes out to like 1 or 0.142 something, 0.28 something.
You're right.
But since we're only doing 3 decimal places, you round it up, so it'll be 0.143. Does that make sense? Okay.
yes.
Well, awesome.
Cool, guys.
So yeah, you were right. Those were some trick questions that had me thinking where I shouldn't have gone to.
Right?
I was pretty sketched out about it too. I was like, I wonder what's gonna happen. That's all right. Okay.
All right, so let's do the next one.
Yes. Let me open that up real quick.
I'm glad we're not going to do this every week because that was a lot of reading. But I also like what you were thinking about, Jocelyn, that we're going to be done with math the whole week.
Yep, and we're not going to have to come back to it. It's going to be so nice.
It is. That's one less pressure to take off, except to make sure the homework stuff gets done.
Mm-hmm.
Yeah.
Okay.
All right, so here we go again.
Does everyone have number or lesson 5 group meeting quiz open?
Yep, that's what I'm getting it. What about you guys?
I'm ready.
All right, perfect.
Almost there. It's open.
I like the 2 gimme questions at the beginning.
Okay, got it.
Those are
I know at least get 2 right.
Okay.
Everyone ready?
Yeah.
Okay. So, the first question, it says, the total area under a normal distribution curve must equal blank. So let me open it.
Yeah, I'm opening that applet as well.
Yeah.
I want to say 95% or would it be 100%?
I am not sure.
Because I remember in the reading it had a 90, an 85, 90. Let me go back to that.
Okay.
Because it was a rule that's there, but I think that's for the standard deviation. I may be reading more into it.
Let's see.
2, 1. 1.
Yeah.
Is it equal to 1?
Yeah.
Yes. In point 2.2 of the book says that the total area under the curve equals 1.
It's true.
Oh, there you go. It says right there. Thanks, Abraham.
Gracias. Okay. Question 4. Under certain circumstances, a normal distribution curve can drop below the x-axis.
That would be false.
Yes.
False.
I agree.
Okay. Distribution curve is symmetric.
Do you agree with that,
Okay.
Abraham? Okay.
Yes.
Number 5. A normal distribution curve is symmetrical.
Wait. So,
I want to say that's true. I'm looking at it right now.
I would.
And it's a bell shape, right? So. So I think it's going to be true.
I think it's true as well.
Mm-hmm.
yeah.
Because even the applet that they pulled up.
Right, and that's what I'm thinking is all the reading when you read about the growing from Ghana and Brazil, everything was symmetrical.
Mm-hmm.
Okay.
Dealing with the standard deviation, it's going to be the standard deviation on both sides of the mean, so that makes it symmetrical.
Yeah.
Okay, so the z-scores. This I had to take a lot of time on, and I still am kind of foggy on that. Oh, the z-score. C is the z-score. That's it. C is the z-score.
C is?
Yeah, the what they put down there in that, because that is the deviation from it. So that's what it is. It's C.
Okay. I can see that.
Because if you go to the reading there, let me take a look here. Yeah, computing z-scores. Because when you scroll down on there, if you scroll down under 3.1, look at the graph there.
Yeah.
It's got z-score right there where C is at.
Yeah. Yeah, I agree with that.
Yeah. Yeah.
You can see.
Okay, yeah. Yeah. Okay. I agree.
Okay.
Question 7. Which of the following elements of the figure represent the probability that the z-score will be greater than 1? I think it's B.
Yes, agree.
B.
Okay.
According to the 68, 95, 99.7 rule, what percentage of the data from a bell-shaped distribution will be within one standard deviation of the mean? As a percentage.
That was in the book as well.
Oh, excuse me.
It's okay. Failure insurance. 84.
So 68%, according to the reading. Wait a minute. What percentage of the? Okay, there we go. So it's 3 standards of deviation, which
That's the same as the area.
Excuse me. Oh my goodness.
None of that. You probably even have to go to work tonight, huh?
I actually might go in for a little bit.
Okay.
Just because my boss is coming back on Thursday. And tomorrow's my day off, so I need to go back and finish a couple things there.
Oh.
Oh yeah. Just for a bit though. It's not too bad.
Okay, there it is. Under this rule, it states that 95% of the observed data will fall within the standard deviations of the mean. So 95% is the answer there.
Okay. But we're not putting the percentage sign, just 90.
Yeah, it'd be 0.95.
But we're not putting it in proportion either.
So it's gonna be 9.
It just
95?
said 95.
Yeah, so it's just
95.
95?
Mm-hmm.
Okay. Suppose that z-scores come from a standard normal distribution. Use a normal probability applet to answer this question. What proportion of the z-score will be between -1 and 1? Give your answer as a decimal, accurate to 3 decimal places.
Okay.
Okay.
Is it the one that would just normally pop up right there?
Yeah,
it
it's
already
just the one that they
defaults
popped up with the same.
So it would be 0.317 then, right? Or am I reading
that's
that
what I
wrong?
would think so as well.
The area?
That's rounding it as well. I may be overthinking. I tend to do that quite often.
We all do.
We'll go ahead and put 0.317,
Uh-huh.
and then we'll do the same thing we always do, where I turn mine in first,
All right.
just to make sure.
317.
Okay. Suppose that z-score comes from yada yada. What proportion of z-score will be between -2 and 2? Okay. So if we put it out, it'll be 0.046.
Wait a minute. No. Are you sure? Because it wants. Okay, you have to go between. So you have to get the middle section,
Sorry,
not the two outside sections. So that actually makes it 0.954 or 955. Because I think what you were doing, Jocelyn, is that you had the two outside sections, and that's the 0.046.
Mm-hmm.
And so you have to unclick those and then click the center section, and that goes to 0.955.
You're right. Okay. Yeah, that makes more sense.
So it's going to be 0.55?
0.955.
Okay.
Because I almost fell into the same trap. It's like, wait a minute, that's outside the lines.
So would number 9 be 0.683?
Well, let me go back to it and change it to ones. And I don't know if you noticed, you just have to change one side. It'll change the other side automatically.
Yeah.
It would still be the 683.
Okay.
What number was that one? Number 9?
Yes.
Okay.
Wait,
Oh, yeah.
I lost right now.
Okay. So the way you look at that, Glenda, is go to that normal probability applet that you have the link in the test to.
I got it.
All right. So make sure that the stuff between the two red lines are in blue, and outside of them are white, and that number that's in the area is your answer. You see how that works?
Yeah.
And so then if you change the z-score down at the bottom, all you have to do is change one number, and it'll change it on both sides of the number, and it'll give you the answer.
So it's going to be 0.975?
For number 10?
For 9.
For 9? No, it's going to be 0.683. Because down in the two boxes down at the bottom where it says z-score, change if you change the one on the right to just the 1.0, it'll automatically change the one on the left. And if the area in between those is 0.6827, so it rounds up to 0.683.
Okay.
Clear as mud?
Yep.
All right.
Okay. All right. So number 12. Look carefully at your answers.
Can we just check 10 and 11, please? Because I'm still kind of like,
What did you get for 10?
Let me check. For 10. I really don't get this.
Okay.
Yet, so
Here, let me show
so many numbers.
Yeah,
Okay.
yeah, go ahead and watch Jocelyn's screen.
Okay.
Okay, I think it's this one. All right. So it'll actually be, I don't know if you see that when I change it over. Okay.
Yeah.
So
Okay.
here, you're going to do -2, and that'll automatically change it on this and on this side. This is what you're focused on. That is your answer.
Okay. Huh.
Because it's between the -2 and the 2 that you're looking for. So it's going to be 0.955.
Okay.
Right.
Oh.
So then do number 11. Glenda, you do number 11 and tell us what answer you get.
Okay. But it doesn't change the blue completely.
Yeah, you have to click inside it and make sure that the outsides aren't blue.
Okay. So it's gonna be, well, I got 0.995. But if I take it to 3, okay. So it's gonna be 9.998 for 3.
997.
997.
Okay. 997. Okay.
So make it a little clearer on understand how to use that.
Yep, pretty much. Bless you.
No problem. All right. So number 12.
Number 12.
It matches the 68, 95, 99.7 rule.
Yes.
Okay.
Okay. So use the following information to answer the next question. Okay. The proportion of the population have a protein requirement that is less than 0.60 grams. Give your answer as a decimal, 3 decimal places. Okay.
What portion? Yeesh.
Portion.
This is the part that confused me a little.
Yes, this is what I was having trouble on as well. Okay, so let me go to the reading here. All right, what's my questions? Close that. Okay, so per kilogram. So if there's 60 kilograms, so it's 60 grams.
What part of the reading is that?
Um, it's down. I think it's 3.2. It might be further down though.
Okay.
Would it be?
Oh wait, is it dealing with the Q plots down in 4? I'll be right back.
Okay.
It's 3.3, I think.
3.3?
Yes, because it's finding the probability of being between two values.
So
Okay.
I had to let my dog in.
oh,
Are you sure that's what it is? Because it's going to round to 3 decimal places.
Yeah, this is one that caught me up as well.
Where?
Oh. Yeah, it is using that. I think Abraham's right, using 3.3.1 of the reading.
That like U is the mean, right?
Yes, U is the mean.
Okay.
Okay.
Population mean requirement.
I forgot that you were. It doesn't. Am I missing something else? Well, I guess it gives us everything that we need to go with, doesn't it? What proportion?
Would it?
Okay, so
Okay, so we're taking it. So it's 0.6. So it's a half of. So it's almost it's less than half of the grams of protein. So, but what's the calculation? How do we? So it's not that calculation that we were looking at earlier.
Lastly, pause for
okay, so
Is 0.07 grams. One proportion of protein requirement is less than 0.6 grams of protein. It wouldn't be 40%, would it?
No, because there's supposed to be 3 decimal places.
Right.
So I got a number, but I'm not sure. I just put, well, I followed the rule that is in 3.31. So it says I put 0.6 minus 0.65 divided by the standard deviation is going to be 0.07, and the number is 0.7142, but it's negative. I'm not sure if that's right or not.
I have an answer, and I think it's 0.714.
That's what I got.
That is for question 13.
What did you get now? 0.0. What was it, Abraham?
No, 0.714.
Yeah.
0.714.
Because it says the first we need to get well, it's asking for the 0.6 population proportion. So we're gonna put that one like the X, and we're gonna minus the 0.65.
So Linda, can you share your? Did you do it on a spreadsheet or did you do it on the computer?
I did on my calculator, so.
Oh, on the calculator. Okay, because I was going to have you share your screen.
Well, actually, I can do it, and I can show it to you. Let me see.
Yeah, if you can share your screen.
Yeah, wait a second.
Okay.
So
0.60 minus 0.65 divided by What was the mean? 0.07. This was my calculation. I don't know if you can see.
Yeah. Pull it up just a hair. Go up a little bit, just a hair. Okay. Oh, okay. That makes sense. What about you, Jocelyn? Does that make sense to you?
Yeah, it
Yeah,
does.
that's exactly what I did too, but I got it on my calculator. So.
Okay. So that's the same thing that you did?
Oh, sorry.
Okay. That makes sense.
Okay.
All right. So what did you get out of that then, Abraham?
0.714.
0.714.
Okay.
Okay. And see here you didn't finish all the reading, but you're teaching now.
Lovely.
Okay, so then
There's more.
all right.
What proportion of the population have a
So
primary
it would be the coefficient of that number. So you just take 1 minus 0.714. That's my thinking. Anybody else have any other ideas?
No.
Well, more. Yeah, because if it's more, oh, well, let me see. So if it's more than 0.6 is going to be
Yeah,
two.
that comes out to 0.286 then.
Yeah. Because you have to sum up 1, right?
Right. That makes sense to everybody?
To 3 decimal places. Let me
Yeah,
check.
so it'd be 0.286. That carries it out to 3 decimal places.
Mhm.
I don't understand.
Okay, so under 60 grams, we have the 0.714. And so since it
Okay.
has to equal 1, the coefficient of that, so if you take 1 minus 0.714, then you have 0.286, because if you add those two together, you get 1.
Mm,
Makes sense now?
more or less.
More or less. That, yeah, you don't sound too convincing, Abraham.
I need to read.
All right, so
So our calculations for 13 were correct.
For what?
Yeah, so
The
you got number 13 right. So in order to find the answer for number 14, you just minus 1 minus your answer you got for 13.
Which is 0.714. No, I mean
Would in
0.71.
turn
Yeah.
give you 2 points.
I think it's the same with question 15.
Oh yeah, I got the same thing because now I use the 0.70 instead of 0.60,
all right.
and I got the same answer. I got 0.7128.
So walk me through that formula again.
It's gonna be what we want minus the mean divided by the standard deviation.
Okay. So 1 minus
Like
the mean. So the
And
mean is 60,
also
right?
divided by
yeah,
Mean is 65.
65.
All right.
And
So-
the standard deviation is going to be 0.07.
Okay. So it would be 70 minus 65 divided by 0.07?
Yep.
Okay.
Yeah, I mean,
65. I come up with 71.428. Is that right?
well, if you get it in decimal, it's 0.70 minus 0.65.
Oh, okay. I didn't use the decimal. That's right. That's what I didn't use. That will change things.
Yes, it's going to be 0.714. But it's the same answer than 13.
Right.
Yeah.
Just have to move the decimal. Okay.
So the probabilities will be the same.
Yeah.
Okay.
I don't know, what do you guys think?
It works that way. Let me go back and put in. So, 0 minus 65 7. Wow, there's only, yeah, it's just a very slight variation. So yeah, it's going to be the same number.
Pretty much.
Right. If we're only going 3.
Mm-hmm. It's going to be the same answer.
I am just I'm having a little bit of trouble with it because hold on. I don't know. Maybe I'm just looking way too into it.
Perro, cállate.
I mean, it all makes sense. I just don't. I feel like something's missing.
Yeah, I'm getting that same feeling, but I don't know what's missing.
Mm,
Oh, let's see.
Wait a minute. So it's a minus. Don't we have to?
Wouldn't
Don't we have to square it?
uh,
We're supposed to square it to not get the negative.
I don't know. Because here in the answer from 3.31 for the C1, it says minus 0.82. And I don't see any square thing. So
But I'm thinking from last week on Thursday. to get the mean, but we're not dealing. Never mind, we're not dealing with mean. We're not calculating mean.
Excuse me.
So I was thinking in the wrong direction.
Because the mean, you don't have to get it. I mean, they give it to you on the. So.
Okay, so if you go to 3.3.1 for number 15, Jocelyn, are you comfortable with where we're at, or?
I still feel like there's something missing, but I might just be freaking myself out.
The overthinking again. All right. So number 16, the formula is there on 3.3.1.
Right.
Yes. We need to subtract both results.
Mm-hmm.
Yeah. So we have to do the same process and just
Right.
subtract. Okay.
Well, I have the numbers written down in there. So we're dealing with a negative and a positive, just like it shows there.
Yeah.
I don't. Okay, I'm confused. I'm reading it and I'm confused there. All right.
I just feel like I don't know.
It's 0.
It's not going to be
Because if it is according to 3.31, then it would be that the second number will be the 65, and it'll be over the 0.07. So it'd be I don't even know what it is.
Because in the first one, if we use a 0.6, the answer is negative. It's negative 0.714. But with 0.7, the answer is positive. So if we subtract, it's going to be 0.
Yes.
right.
So,
Okay, let's just try.
All right. I think I'm following what it says to do here. Okay, so if we go to the probability applet again, and we plug in our numbers. No, that's not the right way.
See, if we plug it into the applet, though, it gives the
Yeah, 0.475.
That's not what I'm getting.
0.525.
What did you put in as the z-score?
The z-score is 0.714. That's what I put. I don't know if that. I don't think that's right though.
Well, actually, no.
That's not.
Because
Okay.
I think
So,
going back to 13 and 14, because Abraham's calculation was the z-score, and so which if you plug that into so that number, instead of being 0.714, when you plug it into the normal probability applet, it should be 525.
525. Yeah, I got it too.
Yeah.
And the
So
other
that-
one is gonna be negative, right?
Well, it should be 525 because that's going to what portion? So that would be the portion of the population is 5.525% or 0.525.
Because see, that's gonna
Because
be the area.
Yeah, because what you guys figured out was the z-score.
Okay.
And then when you plug that z-score into that probability applet, it's going to be
Give us the area.
525.
525. Okay.
But that's
Not
for
on you.
which question?
13.
13.
So it would be 0.525?
Yes.
5. Yeah. I'm following you.
Does that make sense?
It does for me. I mean, right now.
Because the formula that both of you used was to figure out the z-score. But that's not what the question was asking. That wasn't asking what the z-score. With the z-score, it helps us to figure out what that percentage was, which changes answer to number 14.
One, so it can be clear for you.
Right.
Okay, let me share.
Who's sharing?
Let me check. One sec. I'm still providing a text, so.
All right.
Okay, where is it? Right here. So can you see it?
Yeah. Yeah, that's exactly because you and Abraham figured out the z-score, and so it would be the 525.
That's going to be the area for
Right.
the 60.
Mm-hmm.
So it says here, what proportion of the population have primary requirement that is less than 0.60? That's going to be 5 to 4, 5.
Mm-hmm.
And then
And so that makes the other answer 0.475.
60. Mm. 14 is going to be more than 60.
Yes, would be 0.475.
To a 6 instead.
Does that make sense to you, Jocelyn?
Yeah, it does.
Okay.
So it's going to be 0.225.
No, The 0.525 is going to be the answer of 13. And then 0.475 is going to be the answer of 14.
Point two
0.475.
four. Sorry, what was that again?
0.475.
Okay. Oh yeah, because we're
Because it has to equal 1.
Yeah.
Mhm.
Right. Okay, got it. And 15, we have to do what we just did, right? So we're gonna subtract.
But see, then it comes
0.5.
out to the same thing. It's going to come out to the exact same answer.
Hmm.
So somewhere along the
Yeah.
line, we've done something wrong.
We need some vacations
I'm
to clear our mind.
ready for a vacation.
Me too.
Me too. Well, I'm leaving for vacation tomorrow, so.
Right?
Um, I don't know. I don't even know. I'm just,
I'm so confused right now. It's killing me.
Okay. 3.4 has the calculations here. Z-scores the mean and the standard deviation.
Mhm.
So on 3.4, would that be if you scroll down below the graph, would that be the calculations we need to use?
maybe. Let's see.
I think that's that's the formula we have to use. No, that's not going to work. Wait a minute. Would that be something that we could put on the histogram? And how it does all that calculating for us? Because I'm looking on there. Because I'm just looking ahead at the other questions.
Mhm.
I put 60, 65, and 70 for the histogram, and it figures out all the other information for us as well. And it gives it, but I think I don't have enough information to put in there.
What answers does it give you?
Well, it doesn't give me the z-score. I was just looking at like the 35th percentile is 63.5. And then the 80th percentile, which is the last two questions, shows at 68. So I don't think I have enough plots in there. So I wonder if I do like 60 all the way up to 70. So let me see what happens if I do that. No, that's not working either. All right. Oh.
Oh, he's loving me nuts.
Hmm. All right. So it's starting to make a little bit of sense here. So let me see what's happening here.
You can do it.
So, something that I'm kind of referring back to right now is
Uh-huh.
preparation homework assignment.
Uh-huh. Uh-huh.
Looking at the assignment as well as the homework, and they kind of have similar questions. But the way they're doing it is not the way we are doing it to find out.
Okay. So walk us through the way that they're doing it.
Here, let me share my screen real quick. Okay. So this is the question that is similar to number 13. What is the probability that a randomly selected particle has a speed over 2,500 m/.
Mm-hmm.
And this is the answer right here. And so the probability of Z is greater than this. And then this is the answer.
So then how did they figure that out? Okay.
100% sure. Let me see. Because
Okay, so they got the mean.
so basically what they did was probability of x is greater than 25,000 or 2,500, and that is equal to probability of z. So I just don't know. So in this scenario, it would be the probability, because over here is our thing. But
Mhm.
because I'm wondering if they have to. Let me see my calculator. So if I did 1.166. I just don't know how they're getting this from this.
God. Take a look. All right, let's take a look here.
Mm,
All right, so that's how they get the 559. Six come from.
Sadly, I know the answer,
Sadly, you do.
but not the result. The way they did.
What is the answer?
Okay, so I will. It
Yeah, show your screen on that.
yeah. Oh, sorry. Let me show you. Wait. Yep. Okay, so I found this.
Hmm.
And
Okay,
even
so how they figure that out then?
That's the point.
Yeah, that's a problem. They don't show their work.
Yeah, I mean, I can understand that, but what? How did they figure? How did they come to that? I mean, we're close. We're at 714, but they got question 15. Let me take a look here.
So the answer is .762, which in turn would mean that number 13 is .238.
Well, that's
I'm wrong.
well. He's showing us number 15.
Right, but the one above it, the answer
Mhm.
above it, it looks like it's from number 14. So both 15 and 14 are the same answer. But if 14 is 762, then that would mean that 13 is .238.
Right.
We just don't know how they got there.
Right.
And we need to figure that out because obviously they have the answers right. I just don't get it.
But we're right on 17 according to that.
Okay, 17. Yep.
Oh wait, no, that's not the.
That's
We're
the
right on
answer to number
13.
16.
16 is this. Wait.
So Abraham, go back to the page. So see, the answer above number where it says question 15 is actually the answer to number 14. And the answer above number question 16 is the answer to number 15. So both 14 and 15 are .762. And then 16 is the one answer right here above question 17. What is that, .525?
Yeah,
Yeah.
5.
And then the answer for 17 would be the one answer above question 18. Would be is that 623? And then the answer for 18 would be the .709.
I'm confused right now. Oh, I'm a mess. Okay, so 13 is going to be what number in our quiz?
13 still stays at 525.
525. Okay. Okay. 14.
But if 14 on here is 762, then wouldn't 13 be .238?
Okay. So
Yeah.
it's the same answer for 15.
I'm just not getting how they got these answers.
Right. I'm
Because
not
they're
either. I mean,
because they're right. It doesn't show the work.
yeah.
So for 16, we have what number?
17. This one. Right?
What?
I think
Yeah,
this one.
what?
No, we haven't figured out number 16 yet.
16 is?
Hold on,
still-
guys. Hold on, because we need to figure out how they got these answers.
Yeah,
You know,
agreed.
I'm confused right now.
So let's start back at number 13.
Okay.
Okay.
On here, if the answer is to number 14 is the 0.762.
Uh-huh.
Then the answer for number 13 will be 0.238. But we need to figure out how that is.
Oy vey. Okay.
Hey guys, I'll be right back.
Okay.
Mhm.
Okay.
Okay. What proportion of the population have a protein requirement that is less than 0.60 grams? Okay.
And 13, right?
Yes. I think is that answer. So, in the mean is 0.65. Should be should be 0.60. 0.65 because that's the mean, and then I'll be over the standard deviation of 0.27. So that ends up equaling that's the case. And then we have to
So portion.
It's just not sinking in.
Yeah.
I'm rereading everything.
I'm trying to do it on my board to see if anything like stands out, I guess.
Mm-hmm.
Nothing. Oh.
According to another page you're looking at, 13 is 0.238.
Right, but we're trying to figure out how it is that they got that.
Yeah. How did they get to that 0.238?
So, 60. Okay, so we need to get the z-score first. So
Okay.
60 minus 0.65 over 0.07. That was equal to, what was it?
0.714.
0.714. What was the exact?
0.71428.
Okay. So let me go back, open this normal thing. And then 0.7142829.
Yeah. 286 is 4.7.
I got it. Figured it out.
You figured it out. All right. So tell us, show us what you did.
Okay. So literally, here, let me share my screen. Okay. So we have to put the exact, oh, I don't know why that changed. We have to put the exact amount in. So the z-score was 0.7142829. Put that exactly in, and we're trying to figure out what is less than 60. So we cancel that out, and it's only this part. So that's where they get the 238.
Right.
Oh, okay. Oh, so it still is using the applet. So we have to use the, okay.
It just has to be exact.
Oh, okay. So let me. 0.714. What? 329. Okay, so less. That makes sense. All right. So that's how they got that one.
That's how I got that one. And then
Okay.
the obvious one for the next one was I guess
762.
Yeah. So the 762 was it?
Actually, it comes to 0.524 or 525.
But is it just the greater than part?
No, because you still have some outliers, but 52.525% or 52.5% are gonna be getting that in there because you have some of the outliers that are getting more than that.
So what was the z-score for the more than 60?
For the more than so for the 70%, 14286.
286.
Mm-hmm.
So
So it comes to 525 because I want the question is pertaining.
I'm getting the 762 number though.
I'm back. What I've missed.
Jocelyn
Okay.
just discovered.
So, all right. Well, on 14,
Here,
they're wanting to know.
because
Okay.
if
On
it
14,
was 7 or 0.7142,
yeah. So you are correct. It is 762. You are correct because I wasn't taking all of it into account.
okay.
All right. So
14
I get that part. The other one is still 762 as well. All right. So that's how they got that. Okay. That makes sense.
Can you guys explain me? I'm a little lost right now.
Yeah, so basically we just figured out how they got their answers.
Okay.
If here, let me share my screen again. So what was the first z-score? For the less than?
The less than is 0.71429.
42.
For 13,
Yes.
7.71.
0.7. You can just put in 0.714, basically. And then you're gonna make a blank, and because you're only looking for the less than, it's just gonna be this part. And that's how they got the 0.238.
It's not really clear. 0.237.
0.238 because you're rounding it.
Okay. 0.2. Okay, so that's gonna be 14, right?
That's the answer for 13.
Okay. For 13. Okay. And for 14.
For 14, it's just this part and this part of the chart. So you would take this blue out and then just do this and this.
All right. So then for 16, use the same numbers because it's 714
Mhm.
and just highlight the blue section, the middle section.
Just the middle section?
Just the middle section because it's asking find the probability that a randomly selected person will have a protein requirement that is between 0.6 and 0.7. And that's what we already figured up, and that's going to be between the two red lines.
Is that the answer they gave on that place you found, Abraham?
Yes, it's 525.
Okay.
525 for 16.
Mm-hmm. Yes.
Yeah.
Okay.
That makes sense.
Okay, let's check.
Well, I'm glad we got that figured out.
Right.
Because that was a little bit crazy.
So 13 is 238 because what Jocelyn explained me. 14, we have to highlight.
It's 0.762.
0.762. Okay, I got it.
And 15 is 0.762.
let me see, like 0.762, right?
Uh-huh.
And the other one,
Is
15 is the same.
0.525.
15 is 525.
Mm-hmm.
525. Okay.
And now for the
And
percentiles.
16 is 5252.
No, we're working on that now.
Okay.
So number 17 says find the 35th percentile for the protein requirement for round answer to 3 decimal places. Okay. If it's 35 percentile. How does the book say we're supposed to figure them out?
That one is 3.4.
3.4.
Mm-hmm.
Okay. So, that corresponds to 70%.
Ah, okay. So we have to enter, if we put in the probability applet on there, point 0.35, which would be the 35th percentile.
Uh-huh. What is the z-score at that point?
It's at 0.454 is the z-score.
Is that the answer it has on that page, Abraham?
The answer is 0.623.
Okay, so we have to figure out, because it gives us all, and so if you look at the equations there, and we just have to go through the equations. It's basically just basic algebra now, is what I'm assuming. What it looks like to me, actually.
It's the 3.4.
What's that?
It's found on the book.
Yeah, it's 3.4. That's where we're at. All right, so the z-score, we start off with the z-score, and we have z-score is 454. So we start off with 454 equals 261 is the mean. So 60, or is it 65? So it should be 65 divided by 0.07. Did I set that up right?
That is 928.
If you multiply.
So we have the mean and the standard deviation, and we have the z-score according to the chart.
Right. And so
then
if we,
we're just gonna have to cancel everything out on
right,
both sides. Okay, and then so you would bring over. Looks like the standard deviation. You have to cancel that out first.
454 equals times 0.07 equals 65. And then we subtract. Yeah, we've been doing this for 2 hours. How about that?
Lovely.
It's okay. It's gonna be worth it, guys.
It is. I wholeheartedly agree. I just feel bad for you, Glenda. You still have to pack.
It's alright. I have a long night ahead.
454 times 0.07.
I hope this gave me the odds for the lottery.
That would be awesome, though.
Okay.
I'm struggling with math so bad. Like, I haven't been a good student for math, so it's giving me a really hard time.
Yeah, math is a little bit complicated.
Times 0.07.
This math
Like, I get
is
really
as
anxious.
108 though.
Yeah, I got B minus, I think. So
I can't even remember what I got in that class. I don't even think I looked, to be honest. I just remember I did not like that class. It was just
neither.
not my favorite. But okay. What are you getting, Michael?
I'm working on it right now. I put the wrong number in.
Okay.
So do we have an answer for 16 yet?
I'm getting 0.618 is the 35th percentile.
618.
Uh-huh.
1, 8.
And the answer was what, Abraham?
63. Must
That's
be like
for
a
the
difference in the
35th.
So here. Okay. What was the z-score?
The z-score comes to 0.454.
454 equals
0.65 divided by 0.07. So you multiply 0.07 by both sides,
right.
which gives you the 0.03178 equals 0.65.
0.0317.
Yeah, 0.03178
178 equals.
equals 0.65.
So it'd be x minus 60.65 because we're trying to figure out for x.
Right.
So it'd be 0.03178 equals x minus 0.65, and then
So then you add 0.65. X might I used the wrong symbol. So you have to add 0.65 to both sides.
is that what it is? Oh yeah. So
it's 68.178. That makes sense?
What's the result?
6.681 or 0.682. But that doesn't make sense. That's the 5th percentile?
I don't.
hold on. We're having to add 65 to both sides. 65. That crosses out. X is left over. X equals 0.6. But why would it be 0.68?
Yeah, because that doesn't make sense that the 35th percentile of protein is 0.682.
for adding that to both sides. 6, 8. That's not
So there must be a way to do that.
But that's following
Like-
the steps that they just gave us right there. Are you getting the same thing, Jocelyn?
I'm getting that 6.8, or sorry, 0.68, whatever.
682?
Yeah.
Yeah. So we followed all the steps that are right there, right?
That,
So that's got to be the answer.
Okay. Because right now that I put in 0.35 as the
Right. Up at the top.
right, it gave me 0.935
What do you mean?
as a z-score.
And you put 35?
Uh-huh.
0.35 in the area.
0.35 in the area.
Because it gives me the z-score of 0.454.
Here, let me show you.
Okay.
Okay. This is what I'm looking at. That's what I put up there.
Uh-huh.
And this is the number it gave me. It's 0.935.
Yeah, because when I put leave your screen up there. Let me take a look here.
Okay.
Because I'm putting the same numbers in.
Are you putting the 0.35?
Oh, I'm using the middle section. You're using the outside sections.
Oh, yeah.
So if you click in the middle section, it'll change.
But that's what it automatically does when we put that number in.
Uh-huh.
So, here, hold on.
You click on something and I saw an 82.
Because
Oh, sorry.
we're trying to find out for the 35th percentile. But when it automatically does it,
Yeah, because see, I have the middle section highlighted when I do it. But if I click on the outside sections like you have it, then
okay,
the
so
area.
we'll just pull up a brand new normal
Uh-huh.
probability applet.
Uh-huh.
And then put in the 0.35.
Yeah, 0.35.
Okay.
And so.
And we're trying to find for the z-score. Or sorry, the 35%.
Okay.
So that's where I got that number from. So let me see if, I mean, there's probably no way possible, but let me see if this reacts according to what the book says.
Uh-huh. Because now I get that 0.935 that you got because I'm using the outside and not the center sections.
So it's x minus 65 over 0.07. We take out the 7 on both sides.
Mm-hmm.
So 0.7, and what is that? Let's see. Because we multiply 0.07 on both sides. So
Correct.
0.07 times 0.935. And that is 0.06545 equals x minus 65. But then we're adding 0.65 on both sides to cancel out that 65 or that negative 65. So this over here becomes 0.71545 equals x.
But you're still using the outside sections of it.
Yeah.
In my interpretation, you're wanting the inside sections of it.
So it would be, but see, then the area changes when we, here, let me see.
Oh, wait. That is correct because they're only wanting what the 35 percentile is. That is going to be the 35th percentile. So the 0.618 is going to be correct because when you change that area, it's only focusing on that area. You follow what I'm saying?
Sort of. Let me see. Sorry.
Because only 35% of the people of the population are going to be at that point.
Okay.
We're looking at the wrong way.
This is confusing because even on the chart where it's explaining how to find the 90 percentile. Well, no, because we're only trying to figure out the 0.35 percentile.
Well, the next one we're trying to find the 80th percentile.
Right,
Next
but
question.
But the answer. So what is the answer?
0.682.
What was it? Sorry.
0.682.
Was that the answer that was on the page?
No, it's 623.
Okay. Because that's the answer we need to be getting.
All right. Let me walk through this again here. 0.54454 equals minus 65.07.
Okay, so let's try this. Let's try to solve for again. So this is 385. X them out. So 385 times 0.07 equals 0.02695. And then you're adding the 6.5. Okay, even then, it's still more than what it actually is. We're supposed to be getting a negative number, I think. I think I know what I'm doing wrong. Yeah. I got it.
Okay.
I got it.
Woohoo! So,
Okay. So this is what we're doing wrong. We're
All
not
right.
including the negative sign to the z-score. So open up a brand new normal applet thing.
Okay.
You put in, you just highlight blue the left side.
Just the left side.
Just the left side. Leave the middle and the right side white.
Okay.
Okay.
And then it gives you, when you put in the 0.35, it gives you a z-score of 0.385.
Uh-huh.
So you're going to do negative 0.385 because it's just the left side.
Ah, okay.
Equals all of that. And then at the end, it ends up being 0.65 plus, or sorry, negative or minus 0.02695. And that
Okay.
gives you the answer.
All right, so we start off with minus 385.
Minus,
I'm trying to do it so that I understand it as well.
right,
So we
right,
start
right.
off minus 385 equals x minus 0.65 over, or 0.65 over 0.07, right?
Right.
Okay. So then we're going to minus multiply 0.07 by both sides.
Right.
Okay, so let me get to that part. Minus 385 times 0.07. So I got 26.95. Is that right?
26.95, and it should be a negative.
Mine came out positive.
So it's negative
Mm-hmm. So
0.385.
negative. Whoops, here. Let's start over here. I got a negative. Nope. Oh, that's what didn't happen. Okay, so negative 0.385
times the point
times 0.07.
and that gives you the negative
Mm-hmm.
0.02695.
There it goes. Okay, so 0.02695 equals x minus 0.65.
And then you
So
cross
then we're gonna add 0.65 to both sides, which gives me a 0.623. Is that right?
Yep.
Yes.
Okay.
And that's the answer.
Oh,
Ooh.
Wow. Yeah. So
Awesome. Okay.
okay.
So now we know how to do the next one.
Right. So now the 80th percentile, we're just using the scores on the right side of the chart. So we change that to 0.8.
That is what I'm assuming.
It makes sense because you're dealing with the higher percentage rate.
Right. But I wonder if we have to include the middle part as well.
Ah, I think you're right. We do have to include the middle part because the
So
80th percentile. So the z-score on that would be 0.842, but we're dealing with the positive.
correct.
All right.
So it'd be x plus minus, wow,
Yeah.
minus 0.65 over 0.07. We take out the 7 or 0.7 and then multiply 0.07 times 0.842, and that is 0.05894 equals x minus 0.65. And then we're adding the 65s on both sides to cancel out that 65.
And I got 0.079.
mm,
0.079?
Oh, no, I'm sorry. 0.709. I'm sorry. I'm dyslexic tonight.
You're fine. Okay, yep, that's what I got to.
That's right.
Yep,
Right, I'm gonna hold still. Oh.
perfect. We did it, guys.
So
Oh,
18 is what number?
what's that?
18 is what number?
0.709.
0.709. Okay. So I'm gonna go through all of them again just to make sure. Or at least from the 13 through 18.
So happy we did this.
I know, right?
Because, I mean, it was nice just finding the answers, I guess, but it's nice to know how they got the answer.
Well, because when we take the exams, we're not going to be able to reach out to find the answer. We have to know how to figure it.
Yeah.
Exactly.
All right. All right. I'm gonna go ahead and submit. Everybody ready?
Yeah. Okay, it looks like we got one question wrong.
Which one?
It looks like number 8 is wrong.
8. So
For question 9 is 0.683.
Mm-hmm.
Yes. Wow, that is the only one that we missed. All right. So.
Okay.
Oh, within one standard deviation. Oh, I gave the answer. It was that's
90.
the 97 rule. All right, so within one standard deviation, go back up to that. I misread the question. That was my mistake.
it's okay.
It's going to be 68.
Hmm. Okay.
Stop it.
All right, guys. This was awesome.
Is it 68?
Yeah.
All right, so I'm going to go back. I need to go back and redo the quiz. So don't go anywhere. Give me the answers on here.
Okay.
Hang on one moment. Let me get back to there. Come on. There we go. Group meeting quiz.
2.111.
All right, true and true. Number 3, what was the answer for number 3?
Number 3 was 1.
1.
Okay.
Number
Number
4
4.
was false.
Okay.
Number 5 was true.
Okay.
Number 6 was C.
Okay.
7 was B.
Okay.
8 was 9, or sorry, that one's the 68.
68. Okay.
9 was 0.683.
Okay.
10 was 0.955.
Okay.
11 was 0.997.
Okay.
12 was the values.
Okay.
13 was 0.238.
Okay.
14 and 15 are both 0.762.
Mm. All right, 16.
16 was 0.525.
Okay.
17 was 623.
Okay.
And 18 was 0.709.
Sweet. This was a hard fought one.
Yeah.
We can all rest easy tonight.
Yeah.
And there's no more math the entire week.
Ah,
As
All
much as
right.
I love seeing you guys, I'd rather get math.
yeah. That,
We share the same feeling, Jocelyn. No hard feelings. No hard feelings. All right.
Perfect.
All right. Till next Tuesday, then, right? And we're only doing one. one.
Yes.
All right, guys. Thanks. You gonna upload that for us, Abraham?
Yes,
thank
I will
you.
finish recording or you leave.
All right. What's up, Jocelyn?
Are we just meeting same time next week?
Does that
Yeah, it
work
works
for
for me.
everybody? All right. So yeah, 5 o'clock next week,
Mhm.
and we're only doing one on Tuesday. This was a lot of work. All right. Thanks, guys.
Okay, bye.
Bye. Have a good night, guys.
Bye bye.